Hello everyone. We're going to do another physics problem here. Heads up, I got some crazy hiccups right now. I don't know if they're gone or not, so we'll see once I get started. Someone's on a train and somebody else is on a football, playing catch with a football, there it is, throwing towards the back of the train. So first things first, let's draw a picture. So we're told that the train is headed southwest. So the train is headed southwest at 100 meters per second. So this corresponds to an angle from the x-axis of 180 plus 45 degrees equals 225 degrees. Okay. Now someone is on the ground watching me, and I guess I am on the train, and I'm throwing a football to the back of the train. And the velocity of the football with respect to the train equals 10 meters per second. But we know more than that. I can say the magnitude of the velocity is 10 meters per second, but I can also say the direction. It's 10 meters per second flipped in the opposite direction. So this will be northeast. So this will equal 10 cosine of 45, comma 10 sine of 45. Okay. Well, we already expressed the velocity vector of the football with respect to the train. We can easily do the train with respect to the ground. That's going to equal 100 cosine of 225, comma 100 sine of 225. Okay, because remember, this angle all the way around is 225 degrees. And then the next thing we want the velocity vector of the football relative to the ground. So this is the velocity of the train that you would measure if you were sitting on the ground watching me. To put it another way, remember if I threw it towards the front of the train, then you would intuitively expect that the velocity that the person on the ground would measure would be the speed of the train plus the speed of the football. But now the train is at this kind of weird angle, and we're throwing it towards the back. But that's okay. Let's just follow our formulas. Velocity of the football relative to the ground equals the velocity of the football relative to the train plus the velocity of the train relative to the ground. F to G equals F to T plus T to G. I kind of think the train is kind of a mediator between the ground and the football. So now I just plug things in. So for my x coordinate, I'll get these two summed together. So I'll get 100 cosine of 225 plus 10 cosine of 45, comma 100 sine of 225 plus 10 sine of 45. Okay. So let's think about what we expect. This train is moving a lot faster than the speed that the football was thrown at. So I should expect that the ultimate motion that the person on the ground would measure is they would see a football that is moving slower than the train, but in the same direction as the train. Kind of the train overpowers the speed of the football. So these numbers should both be negative, I expect. Everything should be headed in the southwest direction still. It's not like the football, it goes faster than the train or anything. So I get 100 cosine of 225 plus 10 cosine of 45. Oh, what do you know? I get a negative number. I'll get negative 63.6. It's a terrible 6. 6, comma, and I think the other one will be the same. 100 times the sine of 225 plus 10 times the sine of 45 equals negative 63. Okay, and that's kind of what we expected. We expected that ultimately the velocity of the football with respect to the ground is still moving southwest, although it's moving a little bit slower than the train. Um, so how I always think about it, this equation is kind of your fundamental equation for relative velocities. And I mean, if you're ever confused by it, just go back to one dimension. Imagine that the train is moving in the x direction and you throw the football in the x direction. Then, of course, the velocity of the football with respect to the ground is football with respect to the train plus train with respect to the ground. The speed of the football plus the speed of the train. Um, and then we just add vectors on everything, and everything will work out. You just have to be really careful. Maybe something is moving in the negative direction, or maybe something is moving in some weird direction. But this general formula is kind of your best friend and your way to go for relative velocity problems.